everyone, welcome back to our science experiment. Today is a very special day because we have a special guest with us.
Yes, I'm super excited to join as your special guest. I'm Keith and we've got something really cool to show you.
Yes, we're exploring something called Archimedes principle.
It's all about why things float or sink.
Archimedes principle tells us this: when you put an object in a liquid, the liquid pushes back with a force called buoyancy.
And the upward push is equal to the weight of the liquid that got pushed away displaced by the object.
So if the buoyancy force is strong enough to match the object's weight, it'll float. If not, well, it sinks.
Think about a boat. It's heavy, but it spreads that weight across a big area, so it pushes away a lot of water, and that gives it a strong buoyant force to float.
And even a tiny object like a rubber duck floats because it's light and doesn't need much force holding it up.
We'll show you exactly how this works with a simple experiment. Let's test Archimedes' principle in action.
The materials used for this experiment are a weighing scale, a container of sand, an empty cup, and a cup filled with water with a hole.
First, we weigh the sand.
It's 83 grams.
Then, weigh the empty cup.
It's 21 grams.
Now we put the empty cup under the hole and put the container with sand into the water.
Now we see it's 40 grams. Record the weight of the sand in water and then the weight of the water in place. It's 80 grams.
Now I'll do the experiment again and record the data.
First, we weigh the sand.
It's 82 grams.
Then, we weigh the weight of the empty cup.
It's 22 grams.
Now, we put the empty cup under the hole and put the sand in the cup of water.
It's 10 grams.
Now we record the weight of the sand and water, which we all have already done, and then we weigh the weight of the water displaced by the sand.
Grams.
Now we record them down. Now let's look at our experiment results. First, the weight of the small cup with sand was 82 grams. When we submerged it in water, the reading dropped to 10 grams. That means the buoyancy force was 82 minus 10, which is 72 grams. Next, we collect the displaced water. The total weight of the water is 70 grams. So the buoyant force and the weight placed are almost the same. This confirms Archimedes' principle, which says that the buoyant force is equal to the weight of the displaced liquid. We also tried a second measurement, but some water spilled out. That's why the result in the second line of the table is lower and not reliable. So, from my first accurate measurement, we can clearly see that Archimedes' principle holds true. Alright, that's it for today's video. See you in the next one. Bye!